Hello, I am Rahish. Today I am discussing about the NASA's DART mission. As we know, there are two types of disasters. Some are natural and some are man-made. Many of the disasters cannot be predicted, such as earthquakes, solar flares, volcanic eruptions, and many others. But asteroid impacts are a large exception to this. We can know about asteroid impacts in advance, and if we take appropriate measures, we can also save our planet from such events. NASA, with its other international partners, is launching a mission to test a possible method to deflect an asteroid. This mission is the Double Asteroid Redirection Test, or DART. DART is scheduled for liftoff on 24th November 2021 on board a SpaceX Falcon 9 rocket from the Space Launch Complex 4 at the Vandenberg Space Force Station in California, United States. The DART spacecraft will rendezvous with 65803 Didymus, which is a binary asteroid system. In a binary system, one relatively small asteroid orbits a relatively large asteroid. In this case, the larger primary asteroid is a 780-meter asteroid called as the Didymus A, and it has a smaller secondary asteroid named Dimorphos or Didymus B. Dimorphos is around 160 meters and orbits Didymus at a distance of about 1 kilometer. DART will impact Dimorphos because this orbits Didymus rather than the Sun. Hence, it will be easy to observe its changed orbit from the Earth. Its orbit is relatively small, hence it will be easy to recognize any change in that. And along with it, at the time of DART's impact, Didymus will be closer to the Earth. But this asteroid never crosses the Earth's orbit. Thus, this asteroid is ideal for this mission. DART spacecraft will demonstrate a method called a kinetic impactor to shift an asteroid from its current orbit. DART is scheduled to impact Dimorphos on 2nd October 2022. DART will impact Dimorphos at 6.6 kilometers per second, which is equal to more than 23,700 kilometers per hour with its mass of 500 kilograms. Because of that impact, the velocity of Dimorphos is expected to change by 0.4 millimeters per second, which will change its orbital period by nearly 10 minutes. With the impact, the primary spacecraft will be destroyed as well. Hence, to know the effects of the impact, a secondary spacecraft is also incorporated into the mission. This spacecraft is the Light Italian CubeSat for imaging of asteroids, or the Licia Cube, provided by the Italian space agency ASI. It will be separated from DART about 10 days before the impact. It will take images of the impact and the resulting ejecta. DART spacecraft is more than just an asteroid impactor. DART has a single scientific payload, that is the Didymus Reconnaissance and Asteroid Camera for Optical Navigation DRACO. As the name states, this is meant for the navigation of the spacecraft. Images from this will also be used for locating the impact site. DRACO is based on the Long Range Reconnaissance Imager LORRI instrument on board the New Horizons. The LORRI instrument was also the base for the LORRI instrument on board the Lucy mission launched last month. DRACO is more than a camera. It is a telescope with a 208 mm aperture and a 0.29 degree of field of view. And that is very important if you are targeting something very small from a long distance. This type of telescope can provide really clear images of the target from a long distance. But targeting a 160 meter wide space rock 11 million kilometers from the Earth is not a simple task. For this, new algorithms called the Smart Nav or Small Body Maneuvering Autonomous Real-Time Navigation had been developed. This optical system will work in harmony with other guidance, navigation and control or GNC systems to navigate the spacecraft precisely towards its target. DART is equipped with an ion propulsion system called NASA's Evolutionary Xenon Thruster Commercial, the Next C. This is a solar-powered ion thruster which has much better efficiency compared to conventional chemical propulsion systems. DART's power system comprises two rollout solar arrays. These are much lighter and compact than conventional solar arrays. These will be deployed in space and each will be 8.6 meters long. This was first tested successfully on the International Space Station in 2017. A small portion of DART's solar arrays is planned to demonstrate transformational solar array technology, which has very high efficiency solar cells and reflective concentrators, which will provide 3 times more electrical power. DART is also equipped with the CoreSat for control and data handling on the spacecraft. It also has a radial line slot array RLSA, which is a low-cost, high-gain antenna with a compact design. DART's secondary spacecraft, the LICIA-CUBE, is a 6U CubeSat provided by the Italian Space Agency. LICIA-CUBE has two instruments, namely LEA, or the LICIA-CUBE Explorer Imaging for Asteroids, and LUKE, or the LICIA-CUBE Unit Key Explorer. LEA is a panchromatic camera to take images with high resolution, and it is a narrow field camera, while LUKE is a wide field RGB camera for multicolor analysis of the target. The European Space Agency has planned another mission named HERA to study DART's impact in detail. HERA is scheduled to launch in 2024 on board the Ariane 6, which is being developed by the Ariane Group. HERA will reach Didymus system in 2027. HERA will be equipped with asteroid framing camera, LiDAR laser altimeter, thermal imager, and two CubeSats, namely Milani and Giovanitas, and possibly an impactor from Japan. It will conduct a detailed analysis of DART's impact. Originally, DART was part of a much different international project called the Asteroid Impact and Deflection Assessment, AIDA. In this plan, a spacecraft called Asteroid Impact Mission, AIM, was to be launched before DART, and it was planned to conduct scientific analysis of the target asteroid before the arrival of the impactor DART. And it was also planned to study the effects of the impact. Because of this, DART would have had much better certainty of the environment of the Didymus system. But in 2016, Germany was not able to fund its part for the mission, and thus it was cancelled by the ESA. In 2018, AIM was replaced by a smaller spacecraft, which was HERA, and with this, the AIDA mission took its current shape. DART mission will demonstrate the technological capabilities of humankind, and it will prove that we can indeed change our destiny. Thanks for watching my video.